Good evening. This is Galactic bringing you our third presentation of this Saturday, November 19th from Chico, California. We are entering a discussion of the numeric system of the sphere, a discovery which I made this year, which cannot yet be called a scientific discovery because that only happens by consensus. Science is a process of sharing. It is a method of communication, where the only difference between the rational logic we use on an everyday basis to communicate, as well as our emotional communication, which is the norm. But when we communicate scientifically, it's actually not based on anything that we in particular think. Although we are involved, what we're involved with is what the universe says. And that alone is science. The definition of science can be extended to many things, including all the way to technology, which I insist is not a branch of science, at least not today, although it can be constructed that way so that technology would be considered a branch of science, which I think most ordinary people would think right offhand. It's not an unnatural thought, but on closer inspection, there's a much better classification system where technology does not directly fit under the category of science. It's a branch of industry, and industry is a much, much different structure. And science today, as it is construed to be technology, is in that class. It's industrial. And so I argue positively, this is for a positive reorientation toward a common notion of science, which is that it is technology. But that's incorrect. And actually that leads to several serious logical errors if you maintain that point of view, that science is justified by technology. That really is what science is for. No, that is not true. Thank God that is not true. Because if that were true, then you would have to go to university for 16 years to learn calculus if you want to achieve your full potential in science. You're going to have to do what science demands that you do to become a scientist, which is to get a PhD. That takes 16 years, minimum, to reach the top. But that's artificial. The only reason that needs to be done is to qualify you for industrial science. It's not real science. It's industry. That's why you go to school. It's not to learn science. And the STEM, which I believe the S stands for science. Science, technology, engineering, and mathematics. Well, you can scratch off the first one because it's not science. It's technology. And technology is a branch of industry that uses science. It uses the results of science for its own purposes, which is to build things. Is that good or bad? That's not the point. Actually, you could consider it the point. That is why we think of technology so highly, is because it was intended to make life better for all people. It does so to a certain degree, but obviously not to its full potential. For at least a century now, mankind itself has had the potential to end poverty and end war through the application of technology, is to make our lives so good that we don't need to fight. That could have been done certainly within the past 50 years. It could be done right now. Will it ever be done? If I thought so, I would be doing something to make it happen, even if it was just a small part. And I just heard former President Bill Clinton give me a very good word of advice, which is that you can be tough-minded and still have a good heart. In other words, you can still be kind and nice and civilized and genteel and diplomatic and even-tempered and normal, even in the midst of life and death conflict. Former President Clinton is well aware of being in tense situations, and he, I think, earned his laurels. I like President Bill Clinton. I know what politicians are. I know how they get to the top. And so it's a matter of relativity. But when it comes right down to it, a scientist simply has to put saving the earth and saving humanity in a compartment where we have to stay human. And so I'm not telling you what to do. But if you're doing science for the right reason, which I assume you are, I assume you want to, even if you're not sure what that could be, you want it instinctively, or you wouldn't be listening to me, because that's all I do, is talk about what science really is, does, has, offers. Real science. And so it's necessary to be quite objective and not be influenced by emotion. Now that's impossible to completely, you don't really want to be divorced from emotion, because if you were, that would exclude love and a whole number of other things, joy. We don't want to be Vulcans. We're not Vulcans. We are humans. But when it comes to talking about science, you do need to shift your orientation to rational logic, which is ruthless. It simply doesn't have anything to do with emotion, but they always overlap in a human. So when I come against a part of science in its larger aspect, it's not to destroy something. It's not to make something seem hateful. If something is hateful, then you're going to have to make up your mind. I should not try to influence you, or I should be a politician, not a scientist. Scientists are not politicians, but when it comes to doing what science does, we actually have to jump into the fray. Now, I never intended to do that. I'm a freelancer. My career in computer science was as a freelancer. Eventually, I went into regular work with Verizon, of all places, and worked with them for close to 8 years. And I've had obviously, I've survived somehow, which means that I've worked in industry somewhere. We all do. Science, however, overlaps into what we do as humans to survive, because science now, certainly now, offers a means of livelihood, and hundreds of thousands of people around the world. I'm not sure if it's millions, because it would require some kind of analysis of who's a scientist and who isn't, which is a good question. That is, I'll speak for myself, I was raised to think of scientists as on a hierarchy, that the higher the degree, the closer they were to science, to be full scientists. And if you get a Nobel Prize, or you're recognized by your peers in some way for a discovery or a contribution, those are the top scientists. But they're not. They're at the top of their industry, and they're using science for what they do, which can be in many areas. It could be you work on the Hadron Collider, or you work at CERN, as indeed John Bell did. But was John Bell a real scientist, or was he an industrial scientist? He was both. he did real science because he was able to make a contribution to actual science, which is knowledge. Science really grinds out knowledge. It's a big machine that grinds out knowledge from discoveries that are based on experiments that prove a proposition, because the way that science is extended is not just with knowledge, because knowledge can be disconnected, but it's the discovery of relationships, which is not numeric, it's geometric. So that's a brief introduction to where I'm at, and presumably where you would like to follow. Both of us, all of us, are following the same thing. You're not following me. And we don't stand on the shoulders of giants. We stand on the shoulders of the universe. And we as humans do contribute to each other. And so in a sense you can say we do stand on the shoulders of giants. But I don't like that metaphor too much. It has a good point, but it can be better stated. We stand on the shoulders of our predecessors' database. They're really not important as names, although we value them as humans. Albert Einstein was a magnificent human being, and so are all of the scientists. If you examine anyone's life as a human, you're going to find both good and bad. And that's not really the province of science to evaluate that, but as humans, we are involved with other humans, and in science there's no exception to that. I'm at the point where I actually have to cross a bridge that I did not want to cross. I am not, first of all, I'm not an industrial scientist, although I was during my career in a tangential way. Computer science is considered to be industrial science, of course, because it produces computers and computer software. So I was in the industry, so I'm no different from anyone else. So I'm not putting any humans down. I'm not trying to say that our physicists are bad. From the point of view of objective science, there is a problem, though, because science is supposed to roll forward. Of course, it's always intending to make progress. Progress in what? If it's progress in technology, then we've hit the jackpot. Science is a 100% success on Earth. A science itself cannot be faulted. Rational logic is obviously blueprinted into us for our own good. We were meant to be happy, and one of the proofs of that is the fact that we were given as part of our environment, just what we were born into, the ability to use linear algebra. And linear algebra is what creates technology. But is linear algebra what creates science? Only partially. Science is much, much bigger than technology. It's about more than technology. If the goal of science had been to benefit the Earth, then we already know that that's true. But did it benefit the Earth the way it could have? Obviously not. But was that the fault of science? No, it's the fault of governments. It's the fault of the group mind that rules the Earth. Humans are powerless against this individually. A group, like a government, completely overshadows any individual. But life does go on, and we do know now, from logical, rational analysis, more or less on the abstract side, but definitely provable, or at least demonstrable as a valid orientation towards the universe, as such as we find it here on Earth, that we were born into a good situation. Except for governments. Now, is that to say that governments should be disbanded? I think most of us in my generation, and I'm over 65, were raised to consider that. You might think, well, that's a commie, pinko notion, but in the philosophy room, anything goes. You're not going to be damned as a traitor for making suggestions on how to improve the human condition. If you also have AK-47s stacked in your attic, that might be different. Or if you're making overseas phone calls once every couple of days to talk with your allies on some other part of the surface of the earth, that might deserve some attention from authorities. But that's not what we're doing. And it's very important for scientists to stay out of politics. Don't ever let anyone... There are several arguments that are still being used from time to time. You hear them, where scientists should get involved in politics because they're the only ones that can make a difference. That's just horseshit, okay? It's just not at all the case. So, science is two different things. By definition, just common definition, you have to distinguish between two different kinds of science. Now, 200 years ago, that wasn't necessary. It was called natural philosophy. Science was about improving our store of knowledge in every direction. That's quickly been narrowed, partially by the Industrial Revolution, to really become more numeric analysis in order to do calculus, to get jets, to get fission bombs, to get bigger bombs, bigger planes, bigger tanks, bigger cars, refrigeration, heating, the distribution of electricity. All of this came from the Industrial Revolution. Was it good? It was all good. But the governments turned it into something evil, of course. They always do. That's what they do. So industrial science is really not on track. And that's pretty obvious today. But there is a side effect, or you might say a direct effect, from the rise of numeric analysis, because it leaves behind geometry. And I'm afraid that that is a fatal error. Whenever... This has really only happened once, so I can't say whenever. But the effect of the Industrial Revolution in producing a guild of scientists who then have models, and then the government funds them, and then the models become sponsored by the government, because the governments will naturally choose the models that pursue the research that the governments want. That's why we have Hadron Colliders, genetic splicing, and space exploration, which is space domination. You could think of probably countless other examples of how governments take a good thing and make it bad. It's just the way it is with governments. It's nothing a human can do about it. You might have a pie-in-the-sky by-and-by attitude that it'll all work out. Well, if you think so, you're on the side of the governments. They want this to work out too, because they're humans. Even though it's a group mind, the group mind protects its visceral interests. It's not interested in what happens to the population, but the scientists who support the industry are also humans. Just like the Godfather, the President, the generals, the heads of the industries, they all have a hand in the pie. Well, when that happens, the game is over for science. Science cannot exist in that milieu. Science does not go forward that way. It does, however, use basically the same principles of communication. Nobody can do this alone. Science is not a lone venture for any man. If it is, it really is religion. It's logical religion. And that's actually what I intended 14 years ago when I took up astrophysics. It was not to say that I was going to become a scientist. I had no interest in joining the science community. I wanted to be alone. I still do. But now I can't. Because I fell in love with what I saw. And so much did I fall in love with the universe. Galaxies, star clusters, explosions of galactic proportions. I'm absolutely, irretrievably fascinated and in love with that. I will never turn my face away from heaven again. And I do consider it to be heaven, even in the same sense that I was studying it when I was a scriptural scholar for 30 years. But it's just incredible. I actually didn't believe in heaven. It's remarkable. So if I were ever to even think of putting down a human being for being dumb, I would have to be at the top of the list, and anything else I said after that would be 100% hypocrisy. I'm like Paul in that sense, the lowest of the low. Objectively speaking, that's absolutely true. And so now I'm in a quandary, because I've made a vow to science the same way I made a vow to the book, that I would devote my life to it before God. This is my own. You don't have to accept that. You may think I'm out of my mind. You don't have to worry about it. We're all out of our mind in our own way. We just usually don't talk about it. But a scientist has to be at least as honest as he can, right? You don't talk about how you wipe your poo-poo. You don't have to be that graphic. Like you're civilized, but you want to be forthright. You want to be honest. You want to be honest. And honestly, I don't want to join science. I don't want any part of it because it's too confused right now. But I need them. They are my fellows in science. We are all part of the same thing. And I need the mechanism that still exists, which is a consensual peer review. Now, the problem for me, or you could turn it around and say the problem for science, in fact, let's start that way. Let's say there's someone, not necessarily me, but someone who's really not in the industry. They're freelance. They devote a lot of energy. Maybe they devoted more energy in their field to what they've learned than people who've gone through school. That can happen. It's possible, but it's not as common. Because when you're in school, of course, you're more apt to get valid insights because you're under guidance. When you're a freelance, you're not under any guidance. You're all on your own. Well, theoretically, you can pick up stuff from books and lectures, whatever. Auditing, you don't have to be a student. You don't have to be a paid member of the scientific community to make a contribution, theoretically. But realistically, you have to look at it from the point of view of those who would be required by their position to review theories. I wouldn't do it because who's going to screen them? If you have an open channel to be heard, you're going to get a very large percentage of just junk mail. Even well-meaning people, like say myself, say I'm actually have a screw loose, and this has no validity at all, and I've made a fundamental error that I just can't see. Well, then I submit a paper. Now, there is an avenue for anyone to do this called arXiv, arXiv. And this has been recommended to me, and I might do it. I'm not ready to do it yet. That has to be very precise. But let's say I did all this. Let's say 6 months from now. I have a spherical geometry and I've laid it out rigorously. A normal paper written in LaTeX using all the conventions, submitted to arXiv. It's found flawless in the sense of typography, everything, all the references. I'm right in order. I'm missing a professor, but you don't. It's like when you go to court, you're allowed to be your own lawyer. You can decline the use of a lawyer and defend yourself. It's not generally recommended. But I'm in the same position. I'm in that position of having to defend myself now. Now, I'm not attempting to defend myself, but that's a very fine line. Because, of course, you identify with your discovery. It's not something you want to let run away, because then you get megalomaniac, you get defensive, you get your feelings are, oh, you don't like my theory, well then you don't like me. And it certainly can come across that way. Scientists know, just as well as I do as a scientist, we know science itself is ruthless. It has to be. But when you're reviewing theories, let's say it's your desk in a certain number of hours a week, it's your job to review theories. Well, which ones are you going to review first? Of course, from your own institution, your own students or your own professors, they're going to get first dibs. But let's say there is a standard way of doing that, which these are journals, but you usually have sponsorship. Now, I have no sponsorship, and I really have no right or any intent of submitting to a journal. arXiv is meant to be the catch-all for that loner, that 1 in a million perhaps, who is close enough to science to have at least gotten close to the cutting edge where you have to be if you're going to make a discovery, unless you want to just make a discovery and find out that someone else already made it. Well, I actually had to do some research just to be sure that my idea has not been attempted before, either successful or not. It's pretty obvious that if it were a successful theory and it had been submitted before, it would have been accepted, but there's no such thing. So I checked to see if this theory of a spherical geometry has ever been considered. Leave a comment, send me an email, do anything you want to let me know what you know, if you know anything about that, because I can only assume that nobody's ever thought of this. Or if they have, they didn't get far and they didn't write anything. They didn't communicate it. Nobody knows this but me. That's a very strange thought for a man like me to consider, that I might have a secret. You'd have to say it is a secret if only I know it. Well, some secrets don't need to be shared. Maybe it's just for me. I don't think it is. It looks like it's for everyone. A new geometry? This is actually something that I would need to talk about now to convince you that it may have some shred of truth. That's exactly what I'm doing in these lectures. And so tonight, in this lecture, I want to get into the constants that we already know about curvature. Now, this really deals with the circle. There are other curves. There's a whole family of curves, as you know. And these exist both in 2D space, which is the lowest number of linear dimensions in which a curve can happen. That's actually quite profound. Linear space has no dimensionality. It's actually a base unit for dimensionality. That is, on behalf of dimensionality in whatever sense dimensionality is, this is linear dimensionality. Well, the line is therefore the base of that. But then comes orthogonality, which is a relationship, and two orthogonal lines can be used as a coordinate system for extracting two numbers from a curve, because a curve goes off the line. Well, if a curve goes off the line, then it's going into 2D space. And that's two numbers. Each line has a number to make the full coordinate, which is then a two-component number called a 2D number. That's very interesting, everything that I just said. What makes it magnificently interesting is when you make the third orthogonal line, and that's perpendicular to both of the other lines. So now all three lines are perpendicular to each other. That is 3D Euclidean space. That may seem complicated to you or complex, or it might not, depending on your orientation. But it should be compared with one other way of seeing space, because you understand that a line measures distance. A 2D coordinate grid measures the curvature of a line with two numbers. These would be sine and cosine, by the way. But when you have 3D curvature, it's going off the line into two other dimensions. And then you need calculus to get the three numbers using derivatives. And then if you go to 4D, you're stuck with the same problem, and that's what Einstein did. And that's the end. Because actually it's been proved that you can make an imaginary line to extend 1D to 2D. If you do that, you get the complex numbers. It's because of something that's a little too complex to name here, but you could look it up. If you start with 1D, which is simply the straight line, and you make an imaginary orthogonal axis, that's the complex number plane. Extremely valuable for analytics. If you have 3D Euclidean space, you can again do the same trick as you did with 1D to add another line to get 2D, but it's an imaginary line. Einstein used that trick. He had three positive axes for 3D Euclidean space. They're all positive because it measures distance. Now you may say, well, each line has a negative component. That's true. That fills out space. There's no contradiction in the negative aspect. But in the construction of a more complex space than 1D linear space, you're putting together lines. And if you make a fourth one to hyperextend cubic space into hypercubic space, you can only do that in the way that Einstein needed, which is to get it curvature, it has to be imaginary. Because if it's not imaginary, you just get four-stick space. It's called polytopic space. He didn't want that because he was analyzing gravity. And gravity is pure curvature. It's spherical curvature of space. So he needed the standard calculus approach to curvature, which is 4-tensor calculus. And because one of the axes has to be imaginary, it has to be negative in the mathematics. It has to be signed, as it said, as a negative axis. When space is positive, time is negative. That makes hyperbolic space. It's inside-out spherical space. And that's what we use. It's called spacetime. And obviously, that is simply as far as linear algebra can get. It works only on a trick. The same trick that was used to make complex numbers, but complex numbers were an enormous success for industrial science. It just doesn't work in real science. It only works for industrial science. This is science of numbers. Pure numbers, not geometry. The geometry is locked forever. It's locked. Gravity has been defined by Albert Einstein as existing in hyperbolic space. Do you accept that? You shouldn't. It doesn't exist in hyperbolic space. It's forced into a hyperbolic space by the necessities, actually the drawbacks of linear algebra. But gravity is spherical. If only we had a geometry of the sphere. If only we had a number system that could directly, rationally address curvature. For instance, the circle. That's what we're going to get into tonight. The circle can be thought of as a derivative of the sphere in the same way that a square can be thought of as a derivative of the cube. It's merely going down by 1 power on the Pythagorean theorem, actually. as sine squared plus cosine squared equals 1 is the parameterization of the sphere. It makes the sphere equal 1 on a two-component number, which is basically sine for y. It actually should be not sine and cosine, but cosine and sine, because cosine is the x coordinate. It's a fraction of 1. And the sine coordinate is the y coordinate, which is a inverse fraction on a very specific relationship having to do with orthogonality. But it's orthogonality that produces two numbers that are both irrational in order to linearize the irrational curvature. And what we want to talk about today is, why is the circle irrational? Is it? Is there any way out? Is there any mathematical trick by which we can unitize curvature? If we could do so, it would have to be on the circle and the sphere, and then perhaps extend it to parabolas and hyperbolas, which are other kinds of curves. There's lots of curves. But the simplest one, which is analogical to if you have a 1D line, that's all you have. If you have two, there's not much you can do because you can't join them. You can only cross them. Well, that makes a good grid. So x and y, that's very simple. But when you get three lines on the plane, they join into a triangle. And that's the beginning of linear geometry. That is called trigonometry because trig is the number for 3. And everything begins with these three lines. Now in 3D space, what happens is you can extend trigonometry to spherical trigonometry. And then you get non-Euclidean lines on the surface of a sphere, and that's called non-Euclidean geometry. Albert Einstein's formulation of 4D split signature hyperbolic spacetime, which is now the holy grail. It's all that's used in quantum mechanics, and it's all that's used obviously in cosmic physics, is Einstein's 4D definition of universal gravity. We need to see that that's linear. And even though it's in hyperbolic space, which is curved, so you would think, well, Einstein got a handle on curvature. No, he did not. He had to back down in front of the impenetrable veil of irrational curvature. All curvature is irrational. The circle has an irrational parameterization from the point of view of linear space, and there's no way to rationalize it. But that is what we need to do, is to rationalize the sphere. How can that be done? Well, it's easy to say. You simply start out by saying that the sphere has a rational surface number. The area of the sphere would have to be rational. Do you know what is the area of a sphere? It's quite remarkable what it is. And it's a fundamental relationship that must be known ahead of time before we talk about spherical space, because we do have to bring linear algebra with us. I have done so by integrating linear algebra into the new number system. That can be proved to be possible. And in fact, it's more than proved, it's actually been done. For complex numbers, it's a little known fact, but I'll share it with you and you can check this, that complex numbers are actually superfluous because the algebra of the complex number plane can be object oriented, programmed into an object, which is the very thing you're trying to parameterize, which in the case of complex numbers is actually a relationship in 2D space which generates a circular function from the object, which is the plane. It doesn't solve the irrationality of the circle, though. What it does is it removes the need for the explicit notation of complex numbers, which are complex. They're difficult to use. They're non-intuitive. But that non-intuitive aspect can be put into an object, and all of that work and all of that notation disappears into the algebra of the object. That's called object-oriented programming. That also can be done for the sphere, but in this case, it's the integration of the algorithm of the calculus into the result that it seeks to get, which is the representation of the spherical surface. That's what Einstein did. He used calculus to generate a calculus-generated sphere. The problem with it is that in order to do that and to get time into the equation, that was his discovery, is that in making spatial measurements for cosmic space, you have to take into consideration simultaneity, because there's a temporal difference between actions, and the separation is called event space. It's not spatial. It's called a space because that's a geometric term. It is a perfectly reasonable term because it previously had only meant space. But Einstein changed the game. He said there are two spaces. This is actually a different data type. It's temporal space. But we don't have any geometry for temporal space. And there's a good reason for that. It's not linear. That is, you could linearize it, and in fact, that is basically what Albert Einstein's equation does. It linearizes not only space, which is already linearized, but it linearizes time with respect to space. It's actually orthogonal to space. But it doesn't change the nature of the numbers that come out, which are irrational. It just turns out that in the universe, you can't do that because you're not machining anything. You're not doing industrial science. You can't use calculus. You have to accept the universe the way it is. You can't shave off any numbers with calculus. But that's all the cosmic scientists do. And in fact, that's all the quantum mechanists do too. They get close and they crow about how close they're getting, but they can't get it. And that's why they are trying to rationalize something that cannot be rationalized. But we know that we should be able to do it. Well, I'm just beating around the bush. It's very obvious what needs to be done. We have an algebra, a mathematical system that works, and it gets us anything on Earth. Well, we're perfectly within our rights to assume that that should get us anything in the universe too. It kind of is, and that's why we're kind of getting it. But why can't we actually get the understanding that we're looking for? Nobody can understand what they're saying. That's the problem. It's infuriating. It's completely against the tenor and tenets of science. That it's like we're all at the gate. We've come all this way, and all we have to do is open the gate. And we can't. It should have been thrown open in front of us by now, we think. So some fundamental error is being made. It's irrationality of the linear number system. We need to change number systems and integrate to the next higher space. That's spheric space. So, the number of irrationality for the circle is called tau. It's about 6.28. ... That means it's irrational. But it is the calculus result. That is the calculation of the circumference of a circle. It's about 6.28. And you could see that that's about 2 times 3.14. That's because tau is 2 pi. There's an historical reason why we don't use tau. But we need to use tau now. That's the right number. Because it's the number not for the semi-circumference, that's pi. But it's for the whole circumference. That's called tau. That was named in this millennium. Although Euler had already given it a name, it never caught on. And so it was renamed to tau, and that's been accepted. But it's not used. Not very much. I use it exclusively because it's the only right number in geometry, because it represents the circle, not the semicircle. The circumference. So you might ask, okay, I'm talking about the sphere and saying that the circle is our gateway to the sphere. Much in the same way that squared space in linear space is the gateway to cubic space. And in fact, Einstein proved the cubic space is the gateway to hypercubic space, which then can be hyperbolized, which leads to four-tensor calculus. That's a dead end. It works, but that's as far as it can get. You might say, well, that's far enough. For GPS it is, because it's Earth-based. You can still engineer the numbers and make your GPS system work. But if you're trying to compute anything in the universe, you have to take it the way it is. It doesn't recognize irrational numbers. A moment's thought should convince you of that. The universe does not recognize irrationality. Everything in the universe works. There are philosophical debates about that, obviously, but I'll just leave it at that. We believe, whether it's philosophical or perfectly logical, we believe that we should be able to get the answers we're looking for. My whole point of doing this is that's what science does. It gets us the answers that we're looking for. It may not answer our why questions. That will come down to individuals. But at least we'll know what why question to ask. Like, where am I? When am I? Where do I come from? All these questions we want to know. We have to know them if we want to be men. If we want to be real men who don't just live and die in vain, we believe that rational logic is what we're supposed to be doing to get our answers. The truth. The truth of the universe. Whatever that means. Just find it. What does the universe say? Do we know? We're looking at heaven now. That's the right place to look, according to a lot of tradition. A lot of tradition, like every religion says look at heaven. Definitely Christianity and Judaism and Islam say look at heaven. Physical heaven. Not pie in the sky with a harp, none of that. Not imagination. Physics. Now, the ancients didn't proclaim it that way because science really wasn't off the ground yet. So they spoke about heaven as the place that's not earth. God created the heavens and the earth. Well, the earth is just one thing. The heavens is much bigger. And everything else is about it's hell on earth. But God or whatever you want to call it, the universe itself says, look at me. See if I have some truth. I'm much bigger. I was here longer than your earth was. Well, we as scientists we're totally beholden to the universe. Everything we do comes from the universe. We don't do anything except employ whatever the universe already gave us to understand it. Well, we have eyes, we have minds, there's the other surface, and now we've penetrated it. We've penetrated it for a century. Well, with a number of people and the level of science, my God, why don't we have all the answers by now? you can't help but wonder, maybe there aren't any answers. That's not true. Yes, there are. You just haven't asked the right questions yet. Because maybe you don't know how. Maybe you don't know the language. Science doesn't have a question. It's just going forward like a blind elephant. It just surges into the future, and then the governments get on top of it, and now we know what's going to happen. Does that mean that science has failed? No. It means that industrial science is doing what it can to exist on Earth. And it calls itself science, and it parasitizes science. It gets all the scientists it can and pays them magnificently to serve the governments, but is that science? Well, it's not science anymore in the sense of pursuing truth. But is that what science is for if there are no answers? Well, what I say is, let's take a look at the situation. Let's use my method that I was trained in, inductive logic, geometric approach, and take a look at the problem. And I've looked at it for a long time. About 2 years so far. But after a year, I started getting interested in numbers. Not just spherical rotations. Not just the geometry of the universe. I was looking at the number system we use. Because I was trying to get angular frequency. And that I was running into a serious problem. I'm pretty good at figuring out what I need to figure out for my geometric needs. But I kept coming up against the same problem in trying to get a straight answer out of physics. What is angular frequency? And then I found out that I'm not the first person to have noticed there's no real clear definition of what that is. So I checked angular momentum. And there's no definition for that either. There's no clear consensus of opinion in science on anything having to do with angular. You know what angular means? Curved. It's always curvature. We can't get what we need with our linear algebra. It's because we're using lines. We should be using curved lines, shouldn't we? Because then it's direct. Just like with a line produces linear numbers, isn't there another object that produces spherical numbers? What could that be? I'm pulling your leg, but go along with me here. We have the object called the line that produces linear numbers. A linear number system, linear algebra, and calculus. Wow! Miraculous on Earth, hopeless in outer space, hopeless in quantum mechanics. Doesn't work, can't. And now we know why, because I discovered it, but we always knew, it's just that I'm saying it. You're not using curved numbers. You're using straight numbers. They don't match. So no wonder you can't get any understanding. You don't have any geometry, you only have sticks. It's a grid. It's a Lego system. And so that's why nobody understands anything about heaven except by looking at the photographs. Your eyes won't lie, but the numbers do. On Earth, they never lie, because we can force them to tell the truth with calculus. But in outer space and at the quantum mechanical limit, which is inner space, and I've found out they're the same space, inner space and outer space, where they just kind of disappear in and you never get anywhere, it just keeps going in forever. You go out, it goes out forever. To infinities. Well, in multiplicative space, which is spherical space, you would have spherical numbers, but what would be the object? Well, the object for linear space is the line. What would be the object for spherical space? The sphere, yes. Does it have a number system? It has to. It has to have a number system. Because the line does. If the line has a number system, so does the sphere. But how do you get to it? How do you rationalize it? How do you make it work? You discover what I did, which is that add and subtract are linear operations, but multiply and divide are not. They're spherical operators. They only work on the object called the sphere. For the same exact reasons that numbers work on the line, linear numbers work on the line, they do, although they're almost infinitely irrational and has a zero, which is a hole right in the middle. So those are two insuperable problems if you're going for precision. Well, now we have to have precision. Not because we need the numeric precision, although we will get that too. We need the geometric precision. Everything that we're doing now runs up against a quadratic limit. It's called that, so I'm not making that term up just to baffle you. But this is a well-recognized limit. It is a limit, and that's a term used in the calculus, and that's exactly what the calculus does. It breaks a limit. It breaks the limit on irrationality, but that can't be broken. So you're going to have to cheat. You're going to have to cheat. That's calculus. That's cheating. But it works on Earth at our scale because we're already cheating. Nature lets us cheat. We can machine those numbers and make them work just as precisely as we need to build things. But we're not building things in outer space. I mean, we're not building galaxies. They're done. They're finished. So we have to compute them the way they are. Well, they exist in spherical space, not linear. And there you have it. We must have a spherical number system. Well, we always did. We just didn't see it. It was right under our noses. It's multiply and divide. That's a different number system than the linear number system. And it uses the sphere. So what we need to do is see how this changes the game. And that can be summed up by defining tau. Tau is irrational, and so we hate it. We don't want tau. How do we get rid of it? We can't. In linear algebra, it's there forever because it's a permanent relationship with the irrational numbers. It itself is irrational to tell us. You want to get to spherical space? Then you're not going to be able to use your linear number system. Well, then we need to figure out how to get the spherical number system. And I figured it out. It's so obvious that it's insane, but to get to our point, we now got rid of tau. But we actually can't, right? That is, from either aspect, it's still an irrational relationship. But here's what happens. Look at the circle. I'm going to use the circle and then switch to the sphere. It works the same way, believe it or not. This is part of the miracle. On the circle, the circumference, if the radius is 1, which you have to do if you want to use linear algebra, you make the radius 1. And when you do that, the circumference is 6.28 ... And that's the irrational number. Well, we can get rid of that right now. You know how? You change the radius. But you change it to a very specific number. You know what the relationship is between the radius and the circumference? I think you do. What is it? Isn't it, what is it? What is the surface area of a circle? Now that's not an area, but it is a 2D area. It's called the length. It's the measure of the circular distance around the circumference once. A very tricky concept, but if you make the radius 1, then the circumference is an irrational number that we can define as such. It's kind of like shooting yourself in the foot if you want the geometry, because you haven't gotten it yet. It's irrational, so you haven't gotten the geometry is never irrational. Linear geometry sometimes is, but not completely. Because of orthogonality, believe it or not. So spherical space needs a number system, but how in the world are we going to get a number system from an irrational space? It's to redefine the space numerically. You start over and reconstruct your space. You don't use lines, you abandon them. But you can't, and that's why nobody's ever thought of this. You can't abandon linear numbers. And I've already given several lectures on why you can't do that. It's because those numbers are computable. And that's necessary. Computability is part of science. We have to have computable numbers. Well, those are linear numbers. There are none others that can be computable, because 0 and 1 make binary logic. And we have to have 0 and 1. We think. Actually, all we need to continue to use our number system the way we're accustomed to using it is to follow the same rules. But this 0-1 matter is actually locked. I don't know if that's been proved. I'm not even sure well, I'm going to assume that that's been proved. That we can't abandon linear numbers. We will always use them. We're actually hardwired to do so. But are we also hardwired to see and use spherical geometry, space, and numbers? Yes. That's been proved by neurophysiology. In my lifetime, basically, is we are equipped to see in two different ways. We do see lines. We see flat surfaces very well. In fact, instinctively, it's genetically imprinted on us to see a flat screen image as if it were real. That's why we enjoy movies. They look real. They don't look flat at all, because we use the same visual cues to get depth out of a flat screen as we do to get it out of real space where there's real depth. That real depth is missing in a flat screen image. We reconstruct it with our minds. Which means that we see in two modes. We do see spherically, and we also see a flat screen. And we actually can't tell them apart except by extrasensorial means. Not extrasensory, but outside the sensory capacity, the visual perceptual space. When you look at a flat screen and you're convinced you're seeing battle cruisers flying around through space like in Star Wars, it looks real. You're seeing depth, you convince yourself, but then you look away from the screen and you see someone walking, you're actually seeing real depth, right? We can't tell the difference. They look exactly the same. But you can tell that one's real and one's not if you stick out your hand. If you stick out your hand towards the screen, you'll eventually touch it, and then that'll convince your mind that it's a flat screen, because it is. But you didn't see it that way, you had to feel it. In other words, you have to get a different perspective to find out if it's flat or not. We can't tell the difference. That means that we're already equipped to use spherical numbers in our minds. The only question is, what are these numbers? Someone would have to discover them and prove that we can still use linear algebra the same way we always have with those numbers. That's quite a tall order. I am sure that it's probably the best explanation for why nobody ever saw this. But it is only a matter of seeing it, and it's based on the perception that add and subtract are the operator on the line. They're one operator, it's add. And multiply and divide are not linear operators. They're spherical operators, and they operate in spherical space. It's that simple, but now we need to elaborate it. The first thing, and the main thing I wanted to say in this lecture, which lays the foundation for everything else, is the way we get rid of the irrationality of curved space is by obeying the rules of the operator in that space. When we did that for the line, we completed the line. We got 0, we got 1, we got -1. And then we had to deal with the infinities, and that was a problem, and so has 0 been a problem. But at least it works for add and subtract. And then we applied the spherical operators, multiply and divide, as if we could do that. And it fooled us because we can do that with multiply. It's closed on the line. The problem is the multiplicative inverse, division.
is not closed on the line. And therefore, multiply and divide do not work for linear numbers because of division. It's division that produces irrational numbers. And it also leads to a second major problem, which is division by zero, completely undefined. And those are the death knell for linear algebra in cosmic space, because we can no longer cheat the universe by using irrational numbers as if they were rational. We can't do that anymore. We have to accept the numbers of the universe. Are they indeed irrational? No, they're not. For the simple reason that the linear number system is the calculus derivative of the spherical number system. And that's why calculus almost works going back to spherical space, but it doesn't completely work. We still have to throw out the remainder, called the infinitesimal, major source of debate, but it works on Earth and therefore it's holy. I agree with that fully for Earth. It does not work in cosmic space, and I have to take a hard line on that. It hasn't worked. It won't work. It can't work. And I found out why. It's because multiplication and division should have been taught to us as the operator for spherical space. But it's a split number. It would have to be. It's going to have to be two linear numbers. We already know that. Sine and cosine from the circle. Use calculus to get the three derivatives for Euclidean space to do spherical trigonometry. That is what's called geometric calculus. And in 4D space, it becomes a nightmare. Now it's 4-tensor calculus in hyperbolic space, and that's the end. That's as far as you can go to drive into the alley. You've stopped. You can't get out now. And nobody realizes that they're trapped in their car and can't get out. That's really the situation. Only with respect to cosmic science, cosmic physics. That's why it's spavined. That's why it's hamstrung. That's why it can't go on. That's why it's kind of losing its mind. But they all the scientists in the industry, they have no problem with how much they're being paid. And that's the end of that story. Now, the end of our story here, for the time being, as we go on into the truth, the actual number system of the universe, which we've neglected for 2,000 years, begins with the fact that the surface of a circle can be parameterized to a single number, 1. But I already said that it has to be a split number. It's 1 over 1 times 1 over 1, and that generates all the numbers, all the rational numbers, into flat space. But it's not square flat space. It's circular flat space. And you might think, well, that's not the universe, so that's no help. What about on a sphere that's rotating? Doesn't it have an equator that's unique to a rotating sphere, and all spheres in the universe rotate? Well, that's a circle. So it's highly significant. I call that the ring. But now let's switch to spherical space, because that's what we actually will use to compute the geometry of the universe. And maybe not compute, to see the geometry of the universe and know that it works, which will be proved with numerics, obviously. Strictly speaking, it's not necessary in geometry. Geometry is the beginning and end of science. Geometry is the goal, not the numbers. Learn that well. Numbers are an illusion. Numbers are used to metricize a space. But if it's linear space, you're going to have corners. And the universe has no corners. So we have to switch the number system to the spherical number system. That was granted to us by blueprint. We can do it. I've already done it. I'm going to teach it to you. But the surface of a circle is tau. It's 6.28. Do you know what the surface of a sphere is? It's 2 tau. Yeah, quite a symmetry, isn't it? The circumference of a unit circle is tau. And the spherical area, which is equivalent to the circumference in 3D space, that has an equivalent surface measurement. It's 2 tau. 2 tau. We jump from 2D space to 3D space, a jump from 2 to 3, but the relationship on the surface is a jump from 1 to 2. And now we're going to invert the circle. On the definition of the circumference, if I'm not mistaken, is 2 pi r, correct? That's 6.28 if the radius is 1. But look at the relationship. It's the relationship of 1, a distance, to 6.28, dot, dot, which is another distance. That's a multiplicative relationship. 2 pi is tau. It's tau times 1. So the circumference is tau. And that's with respect to 1. What if you reversed that? What if you made the circle 1? What would the radius be? It would be 1 over tau. Now, go to the sphere. What if the surface of the sphere were 1? What would the radius be? It used to be 2 tau, and we just made it 1. So what does that make the radius? Isn't it 1 over 2 tau? Isn't that 1 over 2 tau? I think it is. And so there is where your irrationality goes. It goes into the linear system where it belongs. All irrational numbers belong on the line. They don't belong in curved space. Curved space doesn't use irrational numbers. And I just proved it, although you may not see how. Let me make it more explicit. When you rework your number system from scratch and don't start with a line, you don't have any zero, you don't have anything, but you do have multiplication and division. That's the operator that's looking for an object to have a meaning, right? It's very difficult to see, but it all fits. You construct the space the same way you did for the line, but you assume that the center point is 1. And if you do that in multiplicative space, because you know you need 2 numbers and they're going to have a relationship, well, we found out what that is by constructing the sphere. We turned to geometry and made the sphere. We found out that we can do that by making the center 1 over infinity and the edge infinity over 1. And then make the number for the center the multiplicative identity. Just as 0 is the additive identity for the line, 1 is the identity for multiplicative space. That turns out to be the sphere, and here's why. When you do that, you make the center of the universe a number less than 1, and you make the edge a number greater than 1. Now you multiply them, and that's the relationship between the 2 components of the number. Together, they generate the number 1. They represent the number 1, but the 2 components cannot be 1. Only the sphere has a 1-to-1 to 1-to-1 relationship. It's 1 over 1 times 1 over 1. But if you go to the next number, say it's 2, they still have to multiply to 1. There's got to be 2 components, so the 2 goes out and the 1/2 goes in, because the 1/2 is less than 1, and the 2 is greater than 1, and they multiply to 1. And that fills space with numbers. And that makes the center of spherical space the sphere, not a point. So what's inside? Well, what's outside? Are they different? We don't know yet because the sphere isn't doing anything, and that's the secret we're going into in the next lecture. Even though we just formulated a correct number system for spherical space, we're not sure what it represents yet. We'll be getting to that. Stay tuned. Santa Galactic, bringing you the secrets of the universe, and now the secret that closes out science and begins a new age. of rational science for cosmic space and for quantum mechanics. That's an hour and 15 minutes. I've never gone this long. We'll be right back.